Hello everyone and welcome to this Astro image processing tutorial. This is take 3. I'll be going through image processing on Pixinsight 1.8, and I'll be showing you some basic processes and the workflow that I go through for most of my images. And let's start. So um, first you want to start with obviously stacking your images, and that's for DSLRs and basically almost all cameras. You can go to script, batch processing, and go to batch pre-processing. So you'll see this window pop up. Here you can select your lights, flats, darks, biases by going on these plus signs and clicking your images. So for example, I have my raw lights here. I have my raw darks here. I select all of them, and the same goes for flats and biases. Unfortunately, I don't have flats and biases, so we'll have to deal with it. But when it comes to changing the parameters for bias, I'll recommend linear fit clipping because usually bias frames are around like 100 or so, depending on or 200, depending on what you shoot. And linear fit clipping rejection algorithm works best for having more than 30 subs, so you probably want to use that. For darks and flats, Windsorize is fine. If it's less than 20 or around 20 to 30, Windsorize works best in my testing, and the same goes for flats. And when it comes to lights, you want if you want, you can generate drizzle data. So that's a way of upscaling your image. Coming to registration parameters of drizzle, you probably want to leave it as it is. Although in my testing, pixel interpolation usually works best for Naxos 3, but leave it to auto, and that's fine. Image integration, you probably want to change it to linear fit clipping if you have like more than 30 subs. If you have more than 30 subs, you want to click linear fit clipping. But in my case, I have around 40, so I'll leave it to linear fit clipping. If you have around 20 or less, you probably want to go with Winsorized because in my testing that works best. And once you're done with that, you can go back. And coming to debayer, you can choose the debayer matrix of your camera. So for most DSLR mirrorless cameras, it's RGB, whether you have Canon, Sony, or Nikon. But let's say you have an Astro camera. In that case, you can probably select it depending on what the manufacturer has stated it on their website. Otherwise, if you don't know, you can just leave it in auto, and most probably the software will handle it. After that, when it comes to global options, you want to definitely click on CFA images, check optimize dark frames, generate rejection maps or bottom fits. Coming to cosmetic correction, it's mostly not needed in my images. At least I've never come across a need to use cosmetic correction, so you probably can leave that. After that, you can check your registration reference frame, which is going to be your raw lights. Choose any one, and it will probably uh, plate solve it and then align all the rest of the images to it. And you can then select the output directory where you want your all of the folders to be present. Then you can click on diagnostics and see if it's showing any warning. So in my case, I haven't selected any bias and flats because I don't have them, so I'll have to deal with it. But after that, once you're done with this, you can click on run, and it will show that, and you can click on continue. You want to go to registered, and you'll see a lot of these files. So you want to go to process, all processes, and you want to go to image integration. Here you can select those files in the registered folder, and click on them. As well as you'll see drizzle files in the same folder, in the same registered folder. You want to click them. They will usually have only 1 KB of data because they have not been written yet. Once this image integration task is done, they'll be written. So you can open that. If you're not doing any of the drizzling, then you can ignore all of these steps that I'm saying. When it comes to image integration, average, additive with scaling, noise evaluation, that's fine. If you are generating drizzle data, then you can check it. Otherwise, you can uncheck it. So Coming to buffer size and stack size, so these parameters are important in case you don't have a very good machine. It's a little complicated to explain, but as Pixinsight explains it here, you want to decrease this buffer size if you are experiencing any error in the process module. And coming to pixel rejection, I'd recommend again going for linear fit clipping or Winsorized clipping, depending on how many images you have. Winsorized for if you have like 20 to 30 images or less, and Sigma or Sigma, you can use either of them, or linear fit clipping if you have more than 30 images. That's it, I guess. That's fine. You don't need to get into pixel rejection 2, 3, and large scale pixel rejection. And then you can apply global. So the process module will process it now. One thing that I forgot to mention here is that if you are only integrating without any drizzling, then you can probably double click on the open space and go to the master folder and click on the light, and that will give you basically two images, or three, depending on if you clicked on the clip high range or not. But you want to close the first two images and auto stretch the third one, and this is where you'll see a stacked image. So this is if you don't want to drizzle and move on uh, with actual post processing. But if you want to drizzle your data, then please follow forward. So the main point of that whole process was to actually generate and add data to the drizzle files. So now you'll see that instead of having only 1 or 2 KB of a size, they are having like 1000 kilobytes. So now you can close the image integration, go to process, and go to drizzle integration. So now you can click on add files and select all the drizzle files, click open, and leave everything as it is, and do enable CFA drizzle, RGGB in my case, or else you can just leave it auto, and just leave everything as it is and click global. So now you can go to background neutralization and actually run this. So the first thing you want to do is create a preview, as they call it. So apologies for the bad star shapes. I shot this whole target at f2, f ratio of 2, so it's not that great. There's a little bit of coma and astigmatism. So once you click on the preview, you can go to background utilization and select the preview and click OK. And either you can drag this new instance arrow to the image, or you can press apply and it will apply to the image. So you can re-stretch it, and now there are a couple ways of going about this. So as recommended by most uh, I'd say geeky image processors, they recommend it to run the background extractor first and then run color calibration. But in this case, I'll be doing the other way around, because I feel like the gradient is very less here because we have cropped in a lot. It's only a little bit dark here and bright here. So we can start with color calibration. You can run a script. So I'll quickly explain how to install scripts. You want to go to resources, updates, go to manage repositories, and I'll put this in the description. You basically want to copy these two right here. Click on add and click OK, and copy them in and click on OK. After that, you want to go to updates, check for updates, and it'll download the repository information. You'll probably see like 1 or 2 updates installed. But in my case, since there's no updates, since I've already installed it, it's all done. After that, you want to go to scripts, feature scripts, go to add, and go to this directory and basically click on select folder, and you'll see that there are some X number of additional scripts that are found. So after that, you can click on OK and click on done. So the scripts will be installed by then. Now you want to go to utilities, and first we are going to use auto color. So this will take a little bit of time. After this, you want to run automatic background extractor. You can close everything else and run it on function degree 1, in my case especially, because The gradient is not that bad. And in terms of correction, you want to use division first, discard background model, and replace target image. And you can either drag this arrow to the image or click on the apply button, and it'll do that. After this, you can probably go to correction and go to subtraction and do the same thing again. And I think that looks good for now. You can obviously always run dynamic background extraction, but I'll cover all these little bit more complex processes in another video. This is supposed to be a little bit on the easier side. So this video is supposed to be a little bit on the easier side. So once this is done, I think it's looking good already. You can go to script, go to utilities, and go to delinear again. And now you'll see that the auto STF stretch function has been applied to the image. So I'll delete this preview. So now you can start uh, with your basic processes. So you can start with the easy processing suite. I'd probably recommend going with the denoise first. uh, you can click on the view selected, go to TGV settings and leave everything as it is, just reset everything, and click on run easy denoise, and that'll probably create some masks and get it done. So once that is done, you can go to scripts again, easy processing suite, and go to HDR if you have a high dynamic range target. So in my case, it's not as I mean, there is the core of the Andromeda, which it'll probably make it slightly more unrealistic, but at least you can start seeing the dust lanes a little better than before. So it's a personal preference if you want to do it or not. I'll show you the before and the after. This is the before, this is the after. So it's up to you. I'll leave it at that. After this script, you want to go to star reduction. So always leave star reduction for the end, because that's the most destructive process out of all of these. And you want to create a starnet mask. So if you don't already have a starnet mask, you probably want to go and download starnet 2. It works really well. And create a starnet mask and apply it to this image, and I'll create star mask for you, which you can go to easy processing suite and star reduction, click on this image, go to starnet and click that mask that you have already got. After that, you can click on Adam Block's de-emphasis method. This actually works the best. So Adam Block is again a very famous astrophotographer, and he developed this method, which seems to only reduce the smaller stars and leaves the brighter stars a little bit about the same size. Or you can just use morphological selection, which is probably the easiest. It's similar to the minimum filter that we apply in Photoshop, if there's anyone who has used Photoshop before. And you probably want to test with all the iterations. The smaller the iteration, the lesser the effect it will have on the star shapes. After that, you can run easy star reduction. So I guess that about wraps it up. There's not much more that you can do in terms of like simple image processing. Obviously, there are a lot of complex ways. I'll probably make another video with uh, the I'll probably make another video with a bit more complex process, but this is a good way to get started. In the second video, I'll probably use a little bit of deconvolution and pixel pixel math, as well as some other methods. And you can probably use SCNR. I completely forgot about this. You can use SCNR either in the linear or non-linear state. This is basically a way of reducing all the uh, greens in your image. It's not as destructive, but you can use it either in linear or non-linear form. And it's similar to the Hasta La Vista plugin in Photoshop again, if any of you have used it before. So I'd probably recommend it anyway from zero point 0.4 to zero point 0.6, and then apply it to the image. And it'll remove a lot of the greens, especially if you're using a DSLR. And yeah, that's about it. So thank you for watching. I'll think about making another video with a little bit more complex processes, and I'll see you guys next time.